In this video, we are going to talk about the 2022 Wassce Physics Practical Mechanics Experiment. This is the part 2 of the Mechanics experiment for the 2022 Wassce Physics Practical. So in this particular video, we are going to simulate a likely experiment that you might see during your exam. So let's take a look. So I'm going to use the Mavinhub Physics Lab to simulate the experiment. You can always download the Mavinhub Physics Lab to simulate several physics experiments and learn a whole lot about science. So let's start right away. So this time around, we're interested in principle of moment because that's the apparatus given to you. Something that has to do with principle of moment. And if you take a look at this experiment, we have objective, which is determine the mass of an object using the principle of moment. And if you check the apparatus section, it's very similar to the apparatus you should be expecting for the actual exam. So we've discussed the procedure in the previous video, but I'll just make a quick recap. So this is an experiment where you've been given a knife edge, a meter rule, two masses. M1 is the known mass, M2 is unknown. Then we have the mass of the meter rule acting downward, but that one is known as M0, right? But that is the mass of the meter rule. Then we were told that this knife edge was displaced or should be displaced from the position. So let's take a look at the procedure carefully. So you are provided with a known mass M1 and unknown mass M2. The mass of the meter is denoted as M0 and is unknown. So you are meant to balance the meter rule horizontally on knife edge and record the balance point. Typically, the balance point of a meter should be at the middle of the meter, which is around 50 centimeters. A meter is 1 meter, right? Then the middle should be 50 centimeters. But in some cases, it may not be exactly at 50 centimeters, especially if the meter rule is not uniform. So, but in this experiment, you're expected to actually verify where the center of mass is. Then you note that point. Then you place the knife edge at position P. P could be 60 centimeter or thereabout. So what I mean by that is if this G happens to be at 50 centimeters, the knife edge will be displaced slightly from the center of mass, which could be 60 centimeters. If this happens to be point 0, this is the starting point of the meter rule, and this is the ending point, which has a mark of 100 centimeters. Okay, let's look at the next instruction. You have to suspend M1 at a point Y. So this point Y, suspend this M1 at this point. Then you have to mark that point P1. That is, the distance from mark 0 should be P1. And you should also record D1. So this is P1. P1 is, if this happens to be mark 0, right? From this mark 0 to where this Y is P1. From this point where you have Y to the pivot point is D1. So the next is to suspend the second mass at point Q with a distance of P2 from the 0 mark of the meter such that the meter balances horizontally. So what that means is try to position M2 until you balance the meter. Once you've balanced the meter, note the point where it balances. So if it balances at point P2, that P2 is from this very point to where this Q is, where this mass balanced, then your D2 is the distance between this Q and the pivot point, which is P. So once you've gotten P1, D1, P2, and D2, then the next thing you want to do is to tabulate them. So tabulate the P1, D1, P2, and D2. Then you have to repeat the experiment for different position of M1. So what that means is after the first round, the second round will require you to readjust M1. So if M1 initially was at position 10. So if this P1 happens to be 10, then the next round you may move it to point 15 and try to balance M2 until you've got a balanced meter rule. So you keep doing that for various values of P1. So P1 will be given to you, then the rest will be derived from the experiment. Once you've tabulated all your readings for different values of P1, plot a graph of D1 on the horizontal axis, which is the vertical axis, against D2, which is on the x-axis, that's the horizontal axis. D1 is on the vertical, which is y-axis, D2 is on the x, which is horizontal axis. Then you are expected to determine the slope and the y-intercept of the graph. So these are the precautions you should take note of. If you want to know more about the precautions and every other thing, check the first video. And if you also want to know more about the principle behind it, also check the first video on this series. Okay, so for this simulation, we're going to look at our settings. For this simulation, we're going to have our P1 to vary from 12 to 28. We're going to vary it from 12 to 28 and we'll use a step of 4. Then we're going to use a meter rule whose length is 100 centimeters. Then we are going to assume that our meter rule mass is 25. The simulation requires you to set whatever you want to set so that it uses that. So which means in this experiment, you can change the meter rule mass and perform your own experiment. It's very robust. You can create a different environment. You can even assume that this experiment is taking place in a different planet. For example, you can assume that this experiment has a different center of mass. You can even assume that your experiment happening in the moon, in Mercury, and all of that. You can change it. You can change the acceleration to gravity the way you want, and there are a lot of settings you have for yourself. But we're going to leave this setting like this, and we're going to assume that the knife edge is at 0.55 and the center of gravity of the meter rule is at 0.50 on the meter rule. Okay, so let's get started, and we're going to set a time of 30 minutes. So let's see if we can finish this experiment in 30 minutes. Okay, let's get started. So this is the simulation environment. So within the simulation environment, you can set the value of P by moving the slider. Just ensure P1 is highlighted, then you move the slider, and as you move the slider, you see that the mass 1 is moving along the meter rule. Then if you want to move P2, you switch this to P2, then you move the slider, then the second mass is going to move accordingly. So this is how you actually carry out the experiment using this simulation within this simulated environment. Okay, so let's take a look at the instruction here. So in the reading, the first reading is to set P1 to be at 12. P1 should be 12, right? So let's go to P1 and let's move this to position 12. And once we have it at position 12, you can move it slightly. Then the next thing is you want to adjust this P2, which is the second mass, until you balance the meter rule. So let's try to balance it and see where it balances. So let's increase it a little bit until we have it balanced. So this is balanced, which is perfect. Then what we want to do is to record where it balances. It balances at 90.4. So let's record what we have. We have 90.4. So the next thing we want to do is to determine the value of D1. D1 is the distance between this P, this point, and the pivot point. And that's quite straightforward. If this, we already know that this is at 55. That is, this pivot point is at 0.55. And if this is 12, then just subtract 12 from 55. So that will give you D1. So if you subtract 12 from 55, you are going to get 43. So what about D2? D2 is the distance between this point where you have your M1 and this pivot point. And how do you get that? You subtract the P2. You subtract 55 from P2. So this is this 90.4 you subtract 55 from it, and if you do that, you're going to get 35.4. So let's record the value 35.4. So the next thing I want to do is to repeat the process for when P1 is equal to 16. So what do? You go to P1, you move this to 16, right? Once you have 16, you go back to P2, then you readjust this until you get this meter rule balanced. So here we have, let's get it balanced. So we've gotten balance at, let's say, 87.4. So this is 87.4. 87.4. Then what's D1? D1 is 55 minus 16. And that will give us, how did you get 65 at 55? 55 is where you have your pivot point. So just subtract P1 from it. Then that gives you D1. Okay, so 55 minus 16 will give you 39. Then what about D2? D2 is going to be 57.4 minus 55, and that will give you 32.4. So let's repeat the process for where D1 equals 20. So we go back here, we change this to 20. We adjust this until we get 20. Then we go to D2. We readjust this until we get this balanced. So we keep moving it gradually until we have it balanced. And in this case, we have it balanced at 84.4. So let's record that. So this is 84.4. Then what's D1? D1 is 55 minus 20, and that will give 35. Then D2 is 84.4 minus 55, and that will give 29.4. So now we move to the fourth row where we have P1 as 24. So let's move to P1. Let's adjust it until we have 24. Then we go to P2 and we readjust this until we have it at equilibrium, until the meter is at equilibrium. So this is 81.4. So we go back here and we set this to be 81.4. So what's D1? D1 is 24. 55 minus 20, 24, and that will give 31. Then what about D2? D2 will be 81.4 minus 55, and that will give 26.4. So we'll move on to the last value, which is where we have P1 as 28. So in this case, we have 28. Then P2 is going to be this. We are going to balance this until we have the meter rule at equilibrium. So this is 78.4. So you just set this at 78.4. So what's D1? D1 will simply be 55 minus 28, which will give 27. Then what about D2? D2 will be 78.4 minus 55, and that will give 23.4. So now we are done with the table of readings. So the next question you'll be asked is to plot graphs. So in this particular case, we have to plot a graph of D1 on the y-axis, while D2 will be on the x-axis. So let's move on to that stage. So here's the graph environment. So on this simulator, you have your graph paper right on the app, and you can do your plotting here. So this is how you carry out a good plot. The first thing you do is to define your title. So we want to set the title, and the title in this case will be something like D1 plot of, you can say plot of D1 versus D2. So you start with the first thing you reference is the value on the y-axis, which is the vertical axis, then followed by the x-axis. Then what about the label on the x-axis, that is on the horizontal axis? The label here will be D2. D2 is on the, and the unit is centimeter. Then the next thing I want to do is to label the y-axis. The y-axis is D1. Then you specify the unit, which is in centimeters. Okay, now you've done all the labeling of the axis and the title. The next is to figure out the scale. The scaling is the most challenging part of every graph. The scale, setting the scale will determine how good your plot will look on paper. If the scale is too large, some points will not be on the graph. If the scale is too small, what will happen is a lot of points will be clustered together and you won't have the graph line covering a large portion of your graph. So a quick way to get your scale right is to look at the values on the axis. So let's start with the x-axis. So let's say I want to get the scale. Scale is just like what should be the spacing, the spacing, that is for every centimeter on my graph, what should be the value on the major lines. So that's basically what we are trying to figure out. So the first one you do is to count how many lines you want to occupy. So it depends on the graph you are dealing with. So if I'm dealing with a graph with so many lines, then I will use that. But in most cases, you'll be dealing with a graph paper where you have maybe 5 major lines. So there may be 4 or 5 major lines on your graph. So in this case, I'm going to assume we have, let's say, 5 major lines. So 5 major lines means if you count what you have on the main axis, in this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 on this case, but in most graph paper, the x-axis will be about 5 or thereabout. So I'm going to use what you might see in a typical graph, so which is something around 5. So if you have 5 divisions on your x-axis and you want to leave some space, so you may end up leaving out one of the divisions and you are focused on 4, right? Now, since you have 4 divisions, the next one you do is to take the difference between the maximum and the minimum of what you want to put on this axis. So the maximum and the minimum is what you will take, then divide by the number of lines you want all of them to be on. That will give you an idea of the scale that you should use. But there is something you should consider here. If you are asked to determine the y-intercept or x-intercept, you need to factor that the minimum is not what you are seeing here. The minimum should be 0, because if you tell me to include y-intercept in my graph, it means the line is meant to pass through, is meant to touch this y-axis, right? And when it touches the y-axis, it means x must be 0 at the point where it's touching the y-axis. That means for the x-axis, 0 must be part of the reading. So this is what I mean. Since in this graph we are interested in the y-intercept, the minimum is not 23.4, the minimum is 0, because we want our line to occupy somewhere around here too. So the minimum is around 0. It could be less than 0, but it's around 0, or it can be less than 0. So let's imagine that we are looking at something roughly around 0 as our minimum. Subtract 0 from here, you're going to get 35.4, the same thing. Then divide by the number of division here. The number of division here we assume to be somewhere around 4 or 5, right? If you divide this by 4, you're going to get almost 9. That's 8 point something. So instead of writing 8 point something or 7, if you divide by 5, you get 7, right? What you do is you round it up to the nearest acceptable scale. Now, what I mean acceptable scale is this. Your scale should be something like 2, 5, 1. You can use 1 as your spacing. You can use 2. That is, you can say 0, 1, 2, 3, 4, 5. You can say 0, 2, 4, 6, and so on. You can say 0, 5, 10, 15. But you shouldn't say something like 0, 3, 6. You should not use a spacing of 3 or a spacing of 7 or a spacing of 8. It's not really ideal. The ideal should be something like 1 or 2 or 5 or 10, as the case may be, or multiple of those things I just mentioned. Multiple means multiple of 1, multiple of or multiple of 5, or multiple in terms of 10. Like if you can use something like 2, you can use something like 20, you can use something like 200. And the same thing on the fractional end, you can use something like 0 0.1, 0 0.2, 0. These are ideal values for your scale. Don't use 0.117. They are not ideal at all. So in summary, for the x-axis, we're going to use a scale of 10. How did we arrive at it? We looked at the maximum, which is 35.4. We looked at the minimum, which we expect to be somewhere around 0. We took that difference, which gives 35.4. Then we divided by the number of division that we should be expecting. And I said the number of division that we should be expecting is around 4 or 5. And if we divide by 5, we're going to get 7, about 7. And since 7 is not an acceptable scale, you round it up to the nearest, which is 10. So we're going to use 10 for the x-axis. So for the x-axis, what I mean by 10 is we're going to use something like maybe minus 10, right? Then the step will be 10. Then since we're expecting like 5 divisions, so we can stop around, let's say, 50 or 60, somewhere around there. So we can stop very close to the maximum. So just stop very close to the maximum, which should be somewhere around 40 or 50. So if you stop at 40, it's still acceptable because the last value will be somewhere here. Or if you stop at 50, it's still reasonable. So 40, 60, still reasonable. Okay, so in this case, we are done with the scale. Then the next thing we want to do is to define the scale on the y-axis. For the scale of the y-axis, what we want to do is to take the same approach. The maximum is 43, the minimum is 27. But because we are dealing with y-intercept, it's possible that we are going to we want to see the value of 0 on our graph. So if you want 0 to be part of the graph, then you should take the 0 to be the 0 to be your minimum, right? So if we take 0 to be the minimum, that is, the difference now becomes 43 minus 0, that becomes 43. Then we divide by the number of division we want to see here. The number of division is also roughly around 5 or 6 or thereabout. So if you divide, let's imagine we assume to be that we're going to have 6 division here. If you divide 43 by 6, you're going to get about 7 as well. So because you have about 7, you have to round it up to 10. So since we are rounding it up to 10, then it means we are going to use a division of 10. So same thing here. You can just try something like this. Let's say minus 10. Then you have up to 40, or let's say up to 50. Since this stops at 43, then you can use a step of 10. So this step is 10. So now we've got our scale, very clean, very nice, and our division is about 1, 2, 3, 4, 5, 6. This is about 1, 2, 3, 4, 5, 6. You can use 6 or you use 5 division. So let's move on to the next. Okay, in the next thing, now we've defined our scale, we've done our labeling of all the axes and the title. The next is to actually locate the points on this graph. So how do you locate the point using this simulator? Well, it's similar to the way you locate points on a real graph. So what you do is you look at the x value, the x-axis. When x is 35.4, where's 35.4? So this is 10, so this is 30. So 35 is in the middle, right? Then 35.4, so this is 35, and this is 36. So it means the 35.4 is almost in between 35 and 36, right? So it's somewhere in between this middle and this 36. So it's over here, somewhere around here. Now, what is the value of D1? D1 is 43. So you look for 43, which happens to be somewhere, this is 40. Then for a division of 10, each of these will be 2. This is 2, 4, 6, 8, 10. Then the middle will just be one step. That is 1, 2, 3, 4, and so on. So since we are looking at 43, 43 will be somewhere. This is 43. This is somewhere at the middle here. Somewhere at the middle, and this is what we have. So somewhere here. So, but how do we use the simulator for it? So to locate your point, you highlight this pencil, then you go to that point and you just click. So once you click, it gives you, it indicates the point there. So the next is to indicate the second location. Here we have 32.4 for the x-axis and 39 for the y-axis. So this 30, this 32, so 0.4 is somewhere here. So then this is y-axis, which happens to be 39. So 39 is in between here. So this is 30. This is 32.4, and this is roughly 39. So you just click. Then the next is this 29.4 and 35. This is 29, almost 30, right in between here. 0.4 is very close to 30. Then we have 35. So 35 is this 30. Then 35 should be somewhere at the middle, right? Then this 39.4, which is somewhere here, and we're good to go here. So the next is 26.4 and 31. So this 26.4, 20, this 25, this 26, then this is 26.4, somewhere here, and you have 31. So 31 should be somewhere here. This is 31. So we have this. Then the next is 23.4, 23, which happens to be this 23, then 0.4, then 27 on the y-axis. This 27. That's after the middle, which is 25. Then this is 26. Then 27 is somewhere here. So this 27 and 23.4. So here we have this. So we've got our plots, we've got our points on the plots. Although this point did not cover a very large area, but note that we also factored 0. So this 0 region is also part of what we are focusing on. So if you look at this point, including 0, you see that it covers a large area. Now we are done with the plot. So with the point, locating the point. The next thing about a graph is drawing the line of best fit. That is, you have to connect all these points with a line. So how do we go about it? So let's go about it this way. So to get it done, on a paper, you just put your ruler, adjust the ruler, then you draw a line connecting them as much as possible. So in this case, I'm going to start off somewhere here. Then I'm going to try to see if I can join all the points to the best of my knowledge. This line of best fit touches as many points as possible. Then I'm going to click. So this is my line of best fit. Now I've got my line of best fit, and I've also gotten all my points. So the next is to get the slope. That's the next question you'll be asked. So how do you get the slope on the line? The slope is obtained when is obtained by picking 2 points. It may not necessarily be 2 points on the, it may not be any of this point, it may just be any point on this line. Once you've picked those points, the next thing you want to do is to look for the change in x, in y and the change in x. So let's take a look at how to go about it. So I'm going to take this point, or let me take this point here. Take a point that you can easily find the value of x and y. Then I'm going to take another point, so which happens to be, let me take somewhere around here. So now I've gotten my 2 points on the line of best fit. So what's the y1? Y1 is the first point you picked. So if, for example, this happens to, you can choose, take this to be y1, or you can take this to be your y1. It all depends on how you want to go about it. So let's say I try to take this to be my y1, then this will be my y2. So let's take a look at it. So this smaller one, which is y1, is somewhere around here. So the y value is 20, is roughly 28. So let's type 28. Then y2 is here. So y2 is roughly 40. Then if you take the difference, 40 minus 28, that will give us 12. Then what about x1? x1, if you take this to be your first point, then x1 is this. x1 is whatever you have down there, and that gives 24 points. 24 points is roughly 24. So this is roughly 24. Then this is roughly 33.1. So we can just assume to be 33, roughly 30. Then if you take the difference, that will give you 9. That's 33 minus 24. That will give 9. So if you divide 12 by 9, the slope, that gives you the slope. Slope is the change in y divided by the change in x, and that's 12 divided by 9, and that makes the slope to be equal to 1.333. So it's roughly 1.333. So that's the slope. So now we're done with the graph, and we've got every aspect of the graph plotted. Note that this software allows you to plot graph by yourself. It walks you through the entire graphing process, so you learn a lot. So now let's talk about the question section. Waec is going to give you some questions after plotting. So they may ask you to determine the value of M2. So in this case, the question is, what is the value of M2? Given that M1 is 30, which is the known mass. The known mass is 30. So we have to multiply the slope by 30. And if we do that, so if you multiply 1.333, which is like 4 over 3 times 30, that will give you 40. So this M2 is roughly 40 if you do the calculation. Then you'll be expected to calculate the, in this question we have to get the M2, the M0 rather, which is the slope of, which is the mass of the meter rule, and that you can get by taking minus M1 times Y0 divided by D0. So what is the M1? M1 is 30, Y0 is the y-intercept, then D0 is the distance between the center of mass, the center of gravity, and the pivot point. So this D0, we know that to be 10, to be 5. Y0 can be gotten from the graph. So from the graph, you can calculate your y-intercept. So y-intercept is this. So this is roughly our y-intercept is roughly at minus 4 points. It's roughly at minus 4 points. Minus 4.4. It's roughly at minus 4.4. So that's what's our y-intercept, and the x is 0. At the y-intercept is minus 4.4. The x-intercept is somewhere around 3.2. So let's say 3.2. So that is how you calculate your graph. And there are other questions, but I'm not going to go through all the questions. And I'm going to submit because our time for this experiment is almost up. So you'll be asked other questions aside questions as regard your graph. You'll be asked to calculate some other questions, or you'll be asked to answer some other questions. So let's submit and see how we perform in this experiment. Okay, so in this experiment, we performed quite well with every other aspect except with the question that we left unanswered. We left most of them unanswered. Okay, so this software grades you on every aspect. It tells you how you perform with the readings, with the graph, and with every other aspect of the experiment. So with the reading, we got we got very, very good reading. That is, our reading is precise. It's very, very close to the computer reading, which is more or less like the ideal reading. The computer reading is the ideal reading, so you don't need to be exact for Waec to grade you. You just need to be close to what is ideal. Okay, so this is my graph, and this is the graph of the system. So very, very close. Then we have our component and all of that. So the software grades you on every aspect. So as regards the question section, we skipped some of the question, but that doesn't really matter. That's not the focus of this experiment. So we've talked a lot about this experiment. We've covered a lot, and we've also simulated the experiment you might come across. So you've now seen how this experiment can help you calculate the mass of the unknown, the mass of the meter rule, and the mass of the unknown, the M2, the unknown mass. And if you check the question, you'll see that the mass of the meter rule is 25.05. And from our settings, we actually use a setting of 25, which the experiment predicted to a very, very large extent. Okay, so we have other questions. You can see that for this particular question, there's a working, but I'm not going to go through that. You can get this application and get to know more about how to answer questions related to experiments. So we are going to talk about electricity in our next video. So watch out for the next video.